Microphones, audio. You can't live with them. Can't live without them. Gotta have stuff that sounds good. There are a lot of people on YouTube that enjoy making videos, and they put a lot of production quality in it. I mean, it's unbelievable. I mean, a reality TV show looks like it doesn't have, any production quality, but then you peel back the layers and it actually does have a huge amount of production quality. And really, I just want to bring you guys on adventures as I'm doing computing without the video part getting in the way. And so audio is something we always struggle with, but audio is something we struggle with because I also don't want to spend money, or I want to spend money smartly and then I get myself into trouble. So this is like the type of microphone we use for the news. They all came from Amazon, like the scratch and dent aisle. That might have been a mistake because they've all had their own set of problems. Rhodes honored the warranty and that kind of thing, but they still act weird. And then I got, went through some stuff. Some people on the forum helped me. Thanks, you guys. We got the Schoeps. I mean, look, it comes in this lovely, attractive wooden box. And so this is like what they use on movies. And so this thing is just completely and utterly bananas. This microphone is just unbelievable. It's great. It's called a small diaphragm condenser microphone, but it's got the microphone and the amplifier and that kind of thing. And it's like, man, these are great. This is ludicrously expensive, and we need several of them. And then I looked at this, and it's like I'm looking at this circuit here. So here's the microphone, and this is the amplifier, and this is the XLR feed. And okay, I can't build that. But this I could totally build. Like, this is just an analog circuit. Those are some big ass capacitors. I could literally harvest those capacitors from the, from old graphics cards and stuff. And you can see where I've been doing a little bit of soldering on this one already just because of stuff. And then there's like a little shock mount made out of plastic. And then this large diaphragm is what actually picks up our voice. And this particular microphone is made for you to be kind of close to it and up on it. And we tend to get farther away, so it doesn't work quite as well. The Schoeps microphone works pretty well for being a little bit farther away. So you get better audio. You get the idea of shotgun microphones. Again, scratch and dent. This is our Audio Technica, shotgun microphone. This is a pretty decent microphone. It has kind of high noise. It'll run powered. You can also put a AA battery in there. This microphone is not completely garbage, but again, it doesn't, you gotta be close to the microphone for it to do pretty good. There's also wireless labs. Wireless labs work really well. We use these a lot. These are omnidirectional mics. They still pick up a lot of room tone. So if the room is really echoey and that kind of thing, these will pick it up a little bit more because they're kind of omnidirectional microphones. Whereas, some of these shotgun microphones, especially if they're pointed down, they won't pick up as much of the room tone or as much of the reverb. But the Schoeps, the Schoeps microphone is awesome in terms of you get a little bit of the room tone and a little bit of the reverb and the reflection in problematic rooms, but it's generally not pretty bad, or not too bad. But and you can hold it like a microphone. You can totally use it, up close. You just have to mess with the gain. But I wasn't real super happy about buying more microphones. And then it occurred to me, I've basically got a Radio Shack here in the building, because Radio Shack's not a thing anymore. Obviously I've been doing electronics for a long time. This circuit in here, this is in the Rode NT1, is not super complicated. The circuit in the Schoeps, not super complicated. I can build this, and so we shall. So it turns out I was not the first to have this idea. You go on the internet and you Google Schoeps schematic, because they've been making these things since the 60s. And there's a lot of schematics, there's a lot of stuff out there. There's a lot of detail and information. And that leads you down a rabbit hole. So you order this particular cheap Chinese microphone, and then you can take it apart and you can modify it. You can also get the older version of these, which use a different kind of phantom power, but even people have learned those tricks. Those mics go for over $1,000. But what if you only want to spend $150? Because I got all these analog components. Well, enter micparts.com. Now, if you order the full kit from micparts.com, a dual stereo setup, it's going to be $600. But $600 is a lot better than $3,200. The question is, will it actually perform as good or better than this once I get done building it? Somebody that kind of halfway knows what they're talking about. Because I mean, let's face it, it's like, I've got this original idea, I'm special. And then the darkness reminds us that we are neither special nor have original thoughts. So you search online and you find micparts.com, where they've built an entire cottage industry around supplying all of the parts for everything to be able to do this. So let's build it. So here's the real magic, the real secret sauce. These are matched small diaphragm condenser microphone elements. This part is the hard part. This is the part that would be hard for you to actually build yourself. Everything else is the amplifier, and it's kind of hard to manufacture good amplifiers in bulk. Well, not like millions of units, but like thousands of units, because you don't want to do that much automation. You'll spend more on automation than you will. The bulk of the product cost is going to be the money that you spend on automating it, which is not a good situation. So you just hand pick components and you just hand make it, and it's craftsmanship. So if you get the kit from micparts.com, it comes with an instruction manual, parts, and even some cheap Chinese aluminum. So yeah, it's just a tube. It even looks suspiciously like the Schoeps microphone. It's exciting. Let's build this thing. It's very important to understand that if you're doing this kit, that the actual audio part, the matched part, is very important. So these resistors are hand picked, and they also go with the transistor that's in there with them, which is what's part of the main part of the audio circuit. So you have to be careful not to mix them up and to keep them all grouped together, because the three components together are part of a manually picked set, so that everything will be balanced and work properly. Begin by preheating your thermometer to 650 degrees. That's what it recommends anyway. So the first step is to prime your soldering iron, clean it, make sure that it's, not completely terrible. We're all using lead-free solder around here, right? No, we're not, because lead-free solder sucks. It's one of those times where I really like a sit-stand desk. I got my iron heated, and step one is going to be to smooth the edges of the PCB down and clean it, because it's gonna oxidize and it's gonna be a little weird, because that's just PCB 101. Cleaning is with 99% isopropyl alcohol, so you can have ye olde jar of solder flux, and that will help you. It makes soldering easy. A lot of solders have flux built in. Got my pre-moistened towelette, but it's isopropyl alcohol. You don't want to skimp on this. The napkin is just utterly filthy. And that's just dirt and crap. And you don't want that to be part of your circuit. I mean, analog circuits, if you're not happy when you're soldering this, because it's an analog circuit, it knows, and it'll be, your unhappiness will be imbued in the device, because it's an analog device, and that's just how it works. In terms of prepping the tools, it's you want some wire cutters. These wire cutters are specifically up to the task. Some screwdrivers. Yeah, we got all the accoutrement here. Got it in my little basket. Got heat shrink tubing. All sorts of fun stuff. There's even a little soldering guide telling you not to be a terrible solderer. Although the kit's you should know what you're doing. But people that think they know what they're doing don't actually know what they're doing. There's a parts list. Very nice. This is well documented. A copper clip. I wonder what that's for. Prepare the terminals. Insert a soldered terminal into each of the non-plated holes in your T3. Teflon sleeves in these terminals are normally a snug fit. Trim the terminal pins below the PCB, leaving a length of 4 millimeters, enough to solder a component to later. Do not use your best side cutter for this, as thick terminal pins could nick its blades. Pro tips. Pro tip. Don't use nice nibblers like this. Use something crappier. Like these. Okay, so that's labeled input cap on the PCB. Remember, these are important. We keep these separate until we absolutely, we really need them. Those are the components that do most of the heavy lifting for this audio, and we don't want to mix them up, because if we get the components mixed up, they're literally hand selected. So, don't want to screw that up. Okay, so you want to trim these back a little bit, but leave yourself enough room to actually solder. So, You'll trim them back a little bit, but I'm actually gonna wait to do that since these are a snug fit. So I'll just wait until we're actually getting to the point where we're gonna solder something on them. But we do need to go ahead and clean them. So I've got my isopropyl. They will tarnish normally, so you gotta really clean each one and go ahead and tin it so that it'll be easier to solder stuff to it later. This circuit has 6 diodes, and you have to read tiny, tiny writing on them to figure out which ones go where. With our diodes in place, we are ready to solder, and soldering is actually pretty easy. You know, you can practice on something else, but it's really not too bad. Step 2 is placing our capacitors. Basically, the trickiest thing with that is reading the tiny, tiny capacitors. So once they're placed, we're ready for another round of soldering. Just go slowly and carefully. These capacitors are not polarized, meaning that you can't get them backwards. That's not true of all capacitors, that's just true of these ceramic capacitors. With all the new capacitors soldered, all we gotta do is trim it up. Now, the first round of installing the transistors is actually pretty easy. The ones on sort of the bottom end, you'll have to bend the leads a little bit because these kind of need to sit low on the PCB. Remember, we're installing it inside a metal tube, so if it's too tall, it's not gonna fit inside the metal tube. So you're really gonna have to make sure that all the components are as far down on the PCB as possible. That said, don't force it, because you can't break it. These are fragile things. It also helps if you take your wipe and just wipe the leads down, because it does oxidize. Next up are our inductors. They look kind of like resistors, but they're actually extremely, extremely fragile. They're ceramic, so if you bend it the wrong way, it'll just shatter. So be careful. And also check this out. WiMA audio capacitors. I could totally harvest these off of higher end motherboards. Actually, a lot of the components here you can harvest off of a motherboard because it's going to be the surface mount variety instead of the through hole variety. This type of thing is called through hole. Through hole is easier for soldering to be done by a human being. These guys probably could offer a PCB with all the surface mount components, because you can get those old pick and place machines for basically everything except the through hole components. Probably just the match transistors and the 2 big through hole resistors, and just do that, and then just get this whole circuit with everything installed surface mount. All right, we're ready to marry the resistors to the circuit board. So one at a time. So we got pretty much everything mounted. There's a styrene capacitor we have to solder really carefully. This little copper alligator clip thing acts as a heat sink because the styrene capacitor is extremely, extremely sensitive. So we're going to do that last, and actually we're going to do that after we clean the board with some alcohol, because styrene is very sensitive. Now it's time to put the circuit board inside the kit, but normally you would use a donor microphone, like you would have a cheap Chinese microphone that you bought, but in this case, because it was the kit, they've basically already taken care of that for me. So I've just got the tube and the end of the circuit board, which has some tiny, tiny flathead screws. I'm gonna go find a flathead screwdriver, and then the XLR input, which is gonna does it pre-tinned wires? Yes, yeah, it looks like pre-tinned wires. Nice, they're pre-tinned wires. So we've got a little bit of work to do in terms of getting this thing ready. Now, once you've got your board basically done, we've got to solder the end cap on, and we've got to do some other things here, the XLR connector. But before we solder the very sensitive styrene capacitor, it's important to clean the flux off the circuit board. The flux has electrical properties, and so you'll want to use a cotton swab and Q-tips and isopropyl alcohol. Now, me personally, I use a toothbrush, very gently, toothbrush, isopropyl alcohol, and then pat it dry, but your mileage may vary. So here we can see the mostly complete one and the complete one, and I've used a toothbrush and scrubbed off the crap on the circuit board, and I've got actually another pass to do. Once you use alcohol to clean off the circuit board, you should probably wait like an hour or so before actually finishing the circuit, because you never know if you're going to have leftover alcohol, and it is important to use 99% isopropyl alcohol because you don't want the circuit to really come in contact with water. That would be bad. But you can kind of see the before and after. And in an ideal world, you would also apply like a brush-on conformal coating on this, meaning that it's going to insulate and increase the longevity of the circuit because it basically is a lacquer that isolates the circuit. I mean, lacquer is probably not the right word, but conformal coating, it's a thing. You can look it up. You can order some if you want. If you really want these things to last 10, 20 years. But that's what I'm expecting, so we'll see. Soldering the XLR connector is pretty easy, and it clamps to the circuit board pretty securely, so that part's not really a big deal. Now at this point, the manual walks you through using a simple multimeter just to make sure that everything is good as far as, you know, the levels and the meter, that kind of thing goes, so that you can be sure that you didn't screw up any of the soldering or anything like that. If you soldered the components in properly, the tube should slide on. Seems like that's going to work pretty well. And then a little gold pin in the middle sticks down just below the surface of the mic, so. Now the screws for this are already built into the base, so you just have to unscrew them because they're super tiny and you'll lose them. So it turns out, I'm an idiot. You don't actually take the little set screws out, you can just unscrew them in place. Duh. God, I gotta say, having a sit-stand desk for this and just being able to stand and work on this is actually easier than sitting. Tall people problems. Now in the bag is the desiccant. This pulls moisture out of the air so it can be stored for a long term. And then here's the microphone itself. Because you get two at a time, they make sure they match, so good job. And just screw it together. Now the only thing that's left is to actually plug this in and see how it sounds. Now the manual has a lot of helpful hints, including components you can replace. If you find yourself in a situation like where the voltage is a little high, like if you use the multimeter and test it and the voltage is high, it does come with an alternative Zener diode that you can use to replace the Zener diode on the system, which will bring the voltage down a little bit. It is not necessary for my particular setup here, since the mic sounds pretty good and I've already got one put together. But you will want to clean with a Q-tip finger oils and crap like that off of the wire, especially the gold wire and the other leads here, because as your finger oils oxidize over time, it will lead to more noise than it would otherwise have. So yeah. Okay, we've got both mics put together. Not gonna touch them. The question is, do the mics pop or do anything weird randomly? Am I gonna have to do a better job cleaning them? Okay, that's probably enough silence. How does the mic sound from down here? Is it better from down here because I'm like more on top of it? Or is it actually like doing pretty good there? Or, I don't know. Felis catus is your taxonomic nomenclature, an endothermic quadruped, carnivorous by nature. Oh, I'm in the squeaky part of standing on the squeaky floor. I thought another fun test might be, I mean, since it's like $200 to $300 in parts, another fun test might be with the Audio-Technica AT897. Yeah, stop bothering me. Not you guys. So, you got the DIY mic over here, and we've got the AT897. Now the AT897 is a long shotgun microphone. It's kind of versatile because you can put a AA battery in it, but the thing can supply current, like the Lumix setup here that we have with the Panasonic or whatever. It's totally fine, yeah, no, it's totally okay. So I thought that we might do an audio test with the 897 because it's like, you know, it's pretty cheap. And I had a thing to read for you, so that'll have to do for the silence. It's all about the Pentiums. What y'all want to do? You want to be hackers, code crackers, slackers, wasting time with all the chat room yackers? 9 to 5, chilling at Hewlett-Packard. Working at a desk with a dumb little placard. Yeah, paying the bills with my mad programming skills. Defragging my hard drive for thrills. Got me 100 gigabytes of RAM. I never feed trolls online and I don't read spam. Installed a T1 line at my house. Always at my PC, double clicking on my Mizouse. Upgrade my system at least twice a day. I'm strictly plug and play. I ain't afraid of Y2K. I'm down with Bill Gates. I call him money for short. I phone him up at home and make him do my tech support. It's all about the Pentiums. What? Alright, so the mics are they're about arm's length away. Normally you would have them positioned elsewhere, like up out of frame or whatever, but you can see they're both set up. I've got the Schoeps over here. And the DIY mic over here. So hopefully I got the left and right channels where they're supposed to be. And and there's a very loud 2U server in the next room. So there's like maybe a high-pitched whining sound. But the air conditioners are off. There's a couple computers in here that are on. They're real quiet. But ode to spot. Felis catus is your taxonomic nomenclature, an endothermic quadruped, carnivorous by nature. Your visual, olfactory, and auditory senses contribute to your hunting skills and natural defenses. I find myself intrigued by your subvocal oscillations, a singular development of cat communications, that obviates your basic hedonistic predilection for a rhythmic stroking of your fur to demonstrate affection. A tail is quite essential for your acrobatic talents. You would not be so agile if you lacked its counterbalance. And when not being utilized to aid in locomotion, it often serves to illustrate the state of your emotion. O-Spot, the complex levels of behavior you display denote a fairly well-developed cognitive array. And though you are not sentient, Spot, and do not comprehend, I nonetheless consider you a true and valued friend. So there's an audio sample. Let's give you some silence so that you can also hear like the noise floor and some of the other stuff. If you bring it in and look at it, you look at the waveforms and you look at the audio, you can see that the DIY mic does have a little bit higher noise floor. Now, I think I could probably do a little bit better job with the high impedance part of the circuit and a little bit better job with the conformal coating to insulate that a little better and probably resolve that. One other difference in the mic is that it's very easy to peak the diaphragm in the DIY mic. The Schoeps seems to have some kind of protection against like that unsavory like rattle. So, if you can kind of hear that, it's an unsavory versus sort of an unsavory sound in the DIY mic. But that's actually a symptom of the capsule. And there's not actually anything wrong there. And, having a foam filter on this and mic placement where you would normally have mic placement, you're not going to be up on this kind of mic. These mics are designed they're hypercardioid, so they're designed for, not being right exactly on top of them and doing this kind of work. So overall, I couldn't be happier with you can get all of the parts online for $300 directly from mic parts. If you know what you're doing, you can even get that down a little bit more because you can get the capsule and modify an existing microphone and get a cheap microphone and do that kind of thing. But $300 versus $1,600 for the CMC6, it's an unbelievable hypercardioid microphone. And hypercardioid is great for problematic indoors shooting where the room's going to be super echoey or you're going to get those artifacts. So this project was amazing. And if you're looking to do a similar project, take pictures and share pictures in the Level 1 forums because holy crap, I didn't know this was a thing. And now I know. I'm Wendell, this is Level 1. I'm signing out and I'll see you later. Hopefully in the forums as you built your own mic. Oh, and if the Schoeps mic is not your cup of tea, you want a nice ribbon microphone or something else? Well, the mic parts folks have thought of that too. There's a million different kinds of mics that you might want to modify or clone. So you've got some options. Neat. Stereo. Yeah, I don't know.